Welcome everybody to an Autodesk Inventor tutorial. My name is Mr. Galindo. Now, we have here our CAM vehicle and we have created a setup, and now we're going to create what we call designed programs. Now the programs basically are an algorithm which calculates where we need to move a drill bit over our vehicle to achieve the program's aim. The first program I'm going to create is the drill program, and it basically just enables us to use a drill function to quickly drill out the two axle holes. To do this though, the first thing we need to do, because this is the first program we've got for our coding here, we need to select the tool. Now by doing this, I've got a tool that I've already created, but you would need to create your own new tool to the specifications that we've got. The easiest way to do this is to go to All Tools and go by Type, find the ball mill folder, scroll down until you find the 6mm ball, the first one is fine, and then I would right click and go Edit. Once this is editing and up, we can change the name, the size of it, and all the rest. And we need to do this because it needs to match our 6mm ball mill we use. So, to start with, I'm going to go to General, and I'm going to call this the F1 cutter, because this is what it is. And we're going to turn the coolant off. We don't have coolant on our machine. We're also going to change the material to high speed still, because that's what it is. And we're going to go to cutter now. It says ball mill, it's got the right diameter, but the shoulder length, the flute length, the body length, and the overall length is wrong. The overall length is 75mm. The body length, which is the tip of the cutter to where it moves into the collet, that's what we call this, the collet, or a holder. The body length is 50, it sticks out 50, and the shoulder length, which is the size of the cutting head here, is also 50, because that happens to go all the way to the edge of our holder. The shaft diameter is the same, 6. Quite often tool bits can have an increased shaft diameter and a shoulder length of slightly less, so it looks something like this, and you'd find that this would be the cutting section, this would be the shoulder, and then this bit would be the wide bit of the shaft. You can see that look there. However, that's not what we've got. We've got a shoulder length and a body length that match, because the shaft diameter matches. The flute length in this situation is actually about 48mm. So we've got a slightly larger shoulder than we do flute length. The flute length is the cutting surface of that bit, so wherever there's a cutting edge is the flute. Moving now to the shaft, it's actually probably going to be easier to insert a holder, so we're going to go to holder description, go select, selecting the folder that says holders. I'm going to simply select this one, the BT30 blank 1. It's got a diameter of 1.8 inches or so. Select that, and that just gives us a visualization for the holder there. Now the speeds and feeds are really critical, and hopefully I will have, or another teacher will have explained them to you. I'm just going to run through what our vehicle is. If you're unsure of what the speeds or feeds are, you definitely should be asking. If you want to know more information about it, give it a Google. It's very interesting reading if you like to know about manufacturing. The spindle speed though is 23,000 revolutions per minute for our drill bit, our cutter, and the cutting speed I like to use 3,500mm a minute. Selecting OK now, and that's fine. So this is the F1 cutter, and I'm just going to select that, and that is going to be the cutter we use, and you can see it's now been placed in this orientation. Now this is the right hand side of our vehicle, and when we put it into the manufacturing machine, or the CNC machine, it does manufacture like from here, top along the side. So this is the right orientation. It's a good way to check that you made your work coordinate system in the correct direction as well. We now need to check the geometry. So we need to select the holes that we're going to drill through. These are the two holes. And after we've done that, we're just going to go to the height here. Make sure you click the rear one and then the front one, please. We go to heights. These need to be changed. The clearance height is what the drill bit will move up to move around or move off from manufacturing. Now we can't go much higher than the end of our vehicle, so we need to make sure this isn't above 40, or is 40 exactly. So I changed this to 2.5, and you can see now it says clearance 40 millimeters backwards there. The retract height I'm fine with, it's slightly below the clearance. The feed height is okay. The bottom height we need to change because our drill bit cannot actually go the whole way through the bottom. So I'm going to change this to the origin, and then I'm going to go -4 millimeters. This is to do with the fact that I want it to drill slightly below halfway but not too far. Selecting OK, and that is a drill program. You'll notice that the drill program had a few numbers of percentages there as it's calculating, and we can simulate this now to visualize how this would have worked. Clicking play, you can see the drill coming through and drilling out our 2 axle holes. Perfect. All done. If you'd like to simulate that with the stock, select the stock button and then do the same thing, and you can see exactly where it's going to manufacture. Well done, that was another Autodesk Inventor tutorial.